Have you ever really looked at your phone and wondered, how on earth did this get made? How does it go from just an idea in someone's head to this incredibly complex device that we use every day? Well, it's a pretty wild journey of design, engineering, and a whole lot of problem solving. So let's pull back the curtain and demystify that entire process, from that first spark of an idea all the way to the gadget in your hands. But before we jump into the how, we really need to talk about why this matters and now more than ever. You see, the electronics industry has this enormous environmental footprint, and a lot of it is kind of hidden from view. From the insane amount of energy it takes to manufacture these things to the growing crisis of e-waste, the whole life cycle of our devices has a pretty hefty environmental price tag. And this isn't a problem that's getting better on its own. It's actually speeding up. Some recent studies are projecting that if we just keep doing what we're doing, our information and communication tech could be guzzling more than 20% of the world's total electricity by 2030. Think about that for a second. More than a fifth of all power on Earth. That's wow. And it puts this huge responsibility right on the shoulders of the designers and engineers. So when you're faced with that kind of mind-boggling complexity and you've got this growing environmental duty, where do you even start, right? You can't just start soldering a few things together and, hope it turns into a smartphone. It all has to start with a plan, a blueprint. And honestly, that is the absolute best way to think about it. Imagine a construction crew just showing up to an empty lot and randomly laying bricks. It would be a disaster. They need detailed architectural plans. And it's the exact same thing with electronics. Before a single component even gets chosen, you need a blueprint to bring some order to all that chaos. So the first type of blueprint is what's called a block diagram. Think of this as the simple, high-level sketch. It's not going to show you every last tiny resistor or nope. Instead, it just uses simple blocks for the main parts. Like here's the processor, here's the memory, there's the display, and it uses arrows to show how they all talk to each other. It's really just the basic floor plan of the house, showing you where the kitchen and the bedrooms are going to go. Okay, but for a much more rigorous plan, engineers use something called the V model. And if you look at its shape, it makes perfect sense. The left side of the V is all about planning and designing. You start with the big picture idea at the top, and you work your way down to the tiniest little component level detail. Then the right side of the V is all about testing and validating. You work your way back up, making sure that every single thing you designed was built correctly and actually works. It's like the master construction schedule and the quality inspection checklist all rolled into one. So to boil it all down, the block diagram shows you what the system does. That's your simple floor plan. The V model shows you how the system gets built and tested step by step. That's your master construction and inspection schedule. Simple as that. All right, so we've got our blueprints. Now, let's get our hands dirty and move from that abstract plan to a physical object you can actually hold. This is where the magic really starts to happen. So it all kicks off with conceptualization. This is the brainstorming phase, where you define the problem you're actually trying to solve. Then you move into schematic design. You're using powerful software to create the super detailed circuit diagram. This is the real nitty-gritty blueprint. After that, it's time for prototyping, where you actually build a physical version to see if the darn thing works. And finally, and this is crucial, comes testing. You simulate everything, you stress test the prototype, you try to break it, all to find and fix every single flaw before it goes any further. Now, let's talk about one of the most critical parts of this whole thing, deciding what to actually build with. The bricks for our electronic house. This is the art and the science of choosing the perfect components. And I'm not kidding, this is a huge deal. There are literally millions of different options out there. Processors, sensors, resistors, you name it. And each one has its own special quirks and features. So how on earth does an engineer sift through all that and pick the absolute perfect one for the job? Well, it's a huge balancing act. On one hand, you've got the technical stuff. How much power does it use? How big is it? And, does it actually do what you need it to do? But then you have to weigh all these non-technical things. How much does it cost? Can I buy it from more than one supplier so I don't get stuck if one runs out? And here's a big one. Is it still being made or is it about to become obsolete? And here's a fantastic piece of advice from a seasoned engineer that just shows you the level of detail we're talking about. You can't just read the first page of a component's datasheet and call it a day. Why? Because that first page, it's just marketing. It's the sales pitch, highlighting all the best-case scenarios. The real engineering truth, the stuff you actually need to know, that's buried deep inside all the boring-looking graphs and tiny footnotes. Okay, so let's zoom back out and bring this all back to that big picture we started with. How do all of these tiny detailed decisions, from the V model down to choosing one little component, connect back to building more sustainable electronics for the future? See, it's not just about making things work anymore. Today's designers have to be problem solvers for the planet. They have to tackle these huge issues, everything from sky-high power consumption and mountains of e-waste to the toxic materials we use to build our devices and this throwaway culture we've created with super short product life cycles. But the good news is, engineers are coming up with some really incredible solutions. They're designing these clever techniques that let a device intelligently power down parts of a chip when they aren't being used, which saves a ton of energy. And it goes way beyond the chip itself. They're exploring biodegradable materials and designing devices in a modular way, so they're easier to repair and upgrade instead of just tossing them in the trash. So the next time you pick up a new gadget, you'll know a little bit more about the incredible, complicated journey it took to get to you. The real question for all of us now is, as we move forward, are we going to demand that our devices aren't just smart and fast, but that they're also sustainable? The answer to that question is going to shape the future of technology for everyone.